Introduction to integration. In this video, we will introduce integration as a recall of what you have learned at O level. Definition of integration. Integration is the reverse process of differentiation. This means that if differentiating gx plus c with respect to x is equal to fx, then integrating fx with respect to x is equal to gx plus c. Therefore, integration is reversing the operation of differentiation. With this, we immediately note that integrating the derivative of gx plus c is gx plus c, and differentiating the integral of fx with respect to x is equals to fx. We shall go through the terminology of integration. This is the integral sign. The expression that we are integrating is called the integrand. The whole expression on the left hand side can be read as the integral of fx with respect to x. It is also known as the indefinite integral of fx. The whole expression on the right hand side is known as the general integral of fx. This is the constant of integration, which is usually denoted with a big C. The process of finding the general integral of fx is known as integration. Let's look at example 1. Please read the question. You may pause the video and attempt example 1 before looking at the solution. We shall look at the solution now. Differentiating sine x squared with respect to x gives 2x cosine x squared. To find the integral of x cosine x squared with respect to x, we introduce the factor 2 in the integral by multiplying 2 and half, leaving the factor half outside the integral. This is the same as half times the integral of the derivative of sine x squared with respect to x. This is finally simplified to half times of sine x squared plus c. Do not forget the constant of integration. Let's look at example 2. Please read the question. You may pause the video and attempt example 2 before looking at the solution. Let's look at the solution now. To differentiate x cubed over 1 plus x to the power of 4, we apply the quotient rule. Next, we simplify the numerator and factorize to obtain the required expression. To find the integral, we first leave the factor 3 outside the integral. The integrand is the same as the derivative of x cubed over 1 plus x to the power of 4. Thus, this is equal to 3x cubed over 1 plus x to the power of 4 plus c. We have seen in these two examples how integration is carried out. It usually involves writing the integrand as the derivative of some expression and include the constant of integration at the end of the expression. Now, we shall look at two basic properties of integration. The first property. The integral of a sum is the sum of the individual integrals. In equation, it can be expressed as follows. For example, the integral of sine x minus e to the power of x with respect to x is equal to the integral of sine x with respect to x minus the integral of e to the power of x with respect to x. The second property. The integral of a scalar multiple is the scalar multiple of the integral. In equation, It can be expressed as follows. For example, the integral of 3 over 4x minus 1 with respect to x is equals to 3 times the integral of 1 over 4x minus 1 with respect to x. Standard results in integration. You are urged to refer to the lecture notes for a list of standard results in integration for powers of x, exponential functions, logarithmic functions, and trigonometric functions. You should read through the list of standard results in your notes before proceeding. Pause the video now. Let's look at some examples. You may pause the video and attempt the examples before looking at the solution. Solution to example A. We first apply the first property of integration to split up the integral into sum. Next, we apply the second property of integration to factorize out constant factors in the integrands. Applying the standard results on integration of powers of x, we obtain the final solution. Solution to example B. We first expand the numerator in the integrand to obtain a quadratic expression in the numerator. The integrand can be rewritten as the sum of powers of x. Next, we split the integral into a sum of integrals and take out constant factors. Finally, applying the standard results in integration of powers of x, we obtain the final solution. Let's look at the next set of examples. Solution to example C. We introduce the factor 4 times 5 in the integrand and multiply by a factor 1 over 4 times 5 outside the integral. The integrand is now exactly the derivative of 5x plus 2 to the power of 4. This gives us the final answer as 1 over 20 times 5x plus 2 to the power of 4 plus c. If you have expanded the cubic expression in the first step, note that you will obtain a solution with a different constant term, but they are both acceptable. Solution to example D. We first split the integral into sum and take out constant factors. Integrating 1 over x minus 2 gives ln of the absolute value of x minus 2. Take note of the absolute value sign. Integrating 1 over 3x plus 1 gives 1 over 3 times ln of the absolute value of 3x plus 1. Thus, the second term gives 2 over 3 times ln of the absolute value of 3x plus 1. Don't forget the constant of integration. Let's look at some examples on the integration of trigonometric functions. Solution to example E. We first expand the integrand. Notice that we know how to integrate secant square x and secant x tangent x individually. Now we split the integral into the sum of integrals. Applying the standard results in integration of trigonometric functions, we obtain the final solution. Solution to example F. First, we apply the half-angle formula for cosine x. For some motivation on why we apply the half-angle formula, note that it is a frequently used technique to apply half-angle formula for cosine x in order to cancel the constant 1 term in the denominator. Simplifying, we obtain this. we see that the integrand is actually a square of cosecant function. At this point, we are glad to apply the standard result in integration for cotangent to obtain the final solution. Notice that the factor half is cancelled due to the coefficient of x. We shall summarize what we have gone through. We have looked at the definition of integration as the reverse process of differentiation, the terminology in integration, two basic properties of integration, and standard results in integration. You may now attempt tutorial 17 question 1, 2, and 3. We have reached the end of the video. We hope that you are ready to continue with the rest of the chapter on integration technique.